core team of IRC. Today, I would like to welcome each and every one of you to this very first session of hashtag IRCKT. Before we begin, we would like to introduce you to the session members who have joined. Okay, here we have Mr. Pranshu Tople. He is going to be the mentor for ROS domain we have scheduled for the KT. And yes, along with me is other people. There are core team members as well. So what is KT? Why we are doing this KT is a huge thing to speak. KT initially IRC has launched KT to give its community members industrial teaching. Like when you hear the word KT, knowledge transfer, it does refer to an industrial teaching, and that's why we have started IRC KT. So today, IRC KT will go with ROS Robotic Operating System, and the very first collaboration is with Rick Beetle Labs. And firstly, let me also congratulate for the first year anniversary of Rick Beetle Labs, and congratulations to you, sir. You have completed 1 year for Rick Beetle Labs, and we are very proud, and we are very a very good. It gives us a very good feeling.
Thank
And
you very much, Nikhila.
yes, sir, sure. And speaking about Rick Beetle Labs, guys, like most of you who don't know what it is, I'm sure most of you does know what Rick Beetle Labs is by the name Pranshu Tople. You're very much aware of what it is. So Rick Beetle Labs is a service-based company that provides consultation and hardware as well as software-based innovative and future tech solution to industries around the globe. So the company works on major fields like ROS, robotics, automation, augmentation reality, virtual reality, machine learning, and software development. The more focus will be from Mr. Pranshu Tople. So before, let us not delay anymore, and I request Mr. Pranshu Tople to take on this session. Thank you,
Thank
sir.
you thank you very much, Nikhila, for such a lovely introduction. Okay, then I guess most of the people, as you are part of Indian robotics community, you might be knowing what is robotics in general. Okay, so I will just share my screen and I will start the presentations. But mm, just give me a minute. Yeah, could you see my screen?
Yes, sir.
Uh, okay. So, you guys know what is ROS, what is about robotics in general. So before, but getting into robotics, like there is a vast majority of robotics that is used in industry, but not known to much of the people, and that is robot operating system. So just like the mobile phones that you have, which works on Android operating system or iOS, which is iPhone operating system, and similar to Windows operating system. So similarly, robots also work on robot operating system. So to know more and know more about the robot operating system, I have a short video to show it to you. Okay, so let's watch this video. So this video was made on the 10th anniversary of 10th anniversary of robot operating system. So this video consists of all the robots that are made using robot operating system. So watching this video, you will understand that there are like each and every industrial robot has some connect to the robot operating system. Especially cobots like this robotic arm that you can see. Cobots usually the name cobot is cooperative robots. So the robots must be aware of the surrounding. They must be aware of the people along with whom they are working. So the industrial robotic arms which were previously used, which were heavy duty ABB robotic arms, so those are not cobots because those are not aware of the surrounding. If a robot moves at very high pace, it can damage, make a heavy damage, or if there is a human being, it can harm the human being as well. So that's the reason cobots were made, so that they are aware of the surrounding, and that is how it gave birth to robot operating system. Along with cobots, the other application that mostly used in robot operating system is for autonomous navigation. So previously, in industries and factories, people used to make line following robots or metal strips following robots, so kind of like that. But nowadays, that used to cost a lot because they used to put metal strips all around the industry, and it was a lot of labor work. So that's the reason when ROS was introduced, it was made generalized because in ROS autonomous navigation, you don't need any lines or anything. You can just keep the robot anywhere into an factory and it will start moving, and you can do mapping, you can do navigation, and there are a lot of things. And that's the reason robot operating system got a really high boost in its early days. So we will be knowing more about these later on. But the reason why I was saying this is because I wanted you to know what exactly robot operating system potential is in the market currently. Okay, so here are some robots that are working on robot operating system, even self-driving cars and a lot of stuff. So it's like, and this video is around 5 years old, I guess. So even then, there were so many robots, and right now it's really booming currently. So that was it for the video. Let me just stop sharing this thing. Yeah. So this was a generalized idea that what robot operating system currently is available in market. Okay, and one more thing, I won't be able to see the chats or something like that. So if you have any doubts, if you guys have any doubts, just unmute yourself and ask there itself. Okay, stop me there itself. So coming to the point, uh, so this is why robot operating system is used in industry, and uh, we started to work around robot operating system around 3 years ago. We started by making some small robots that we were testing in our labs, and then we started consulting companies for making their own robots. So Rigbetal Labs currently is not a product-based company. We don't have our own robots. We help other companies build their robots. So that is what we primarily do. Okay, so as this is like the first year anniversary of Orbital Labs, we are doing something huge. We are planning something huge, and we are introducing our first product that will be also open source robot. Okay, so you don't need to buy it; you can even make it on your own, and that is what we are doing currently. And I have a short video for that as well. So I will be sharing a link in the chat, so I request everybody to check out the chat, go on to that video, and once you watch that video, come back here again. Okay. So I remember that video is around 1.5 minutes long. So go and watch this video and come back 2 minutes later. Okay. Can everybody see my message in chat?
Yes, sir, it is visible, and I
Okay.
think
Okay.
people are looking for the
Yes.
video.
Please don't spam the message chat section right now. So everybody just click on that video and come here again.
Okay, so I hope everybody has watched that video, and this is a huge surprise that we are launching our own product, our own first product on our birthday of Rigbital Labs. So again, I will share my screen and I want to show you a couple of things. So right now, if you go on to tortoisebot.com, so you just go on to tortoisebot.com, you will get the website to buy our own first product, which is TortoiseBot. It is a clone version of the well-known ROS-based robot TurtleBot. But the major factor over here is we are selling this robot at 1/4 of the cost of TurtleBot. So the TurtleBot costs around starts at rupees 60,000 in India, and it has similar functionality that TortoiseBot has over here. Okay, so if you go on to tortoisebot.com, you will get this website. You will see all the features that it has. Uh, and as I said, this is going to be completely open source. So you can, even if you don't want to buy this robot, if you have most of these parts, you can just go onto our GitHub page and you will find all the instructions over there, and you can build your own robot. And but if you build your own robot, there is one catch, that is, if you list down all the parts that are required to build this robot, it costs you around 17,200 rupees. But if you buy it from us, you will get it at an offer price of just 14,999. Okay, so that is the major thing. And if you go it, you can program it in Python and C++, which we will be learning in this knowledge transfer program as well. So we'll be learning how we can make Python codes, how we can make C++ codes for ROS-based robots. Currently, the applications are like, it can be teleoperated. So it can be operated using the keyboard of your computer, or it can be operated using a gamepad. It can also do mapping. It can do navigation, and it has computer vision capabilities. It can detect objects. It can follow objects. There are a lot of things that it can do. And our team is even right now working on making more and more packages for TortoiseBot. So I hope you have seen this video, so you might be knowing what all things are already there. So if you just want to pre-order it, you can just pre-order it at the price of 4,999, and if you want to pay it in full, then you get a discount of rupees 1,000. So if you want to pre-order, just click here and choose whatever payment you want to do. If I select full payment, you can just fill up this form, and TortoiseBot will get delivered to you. By the it will be shipping will be started like the first week of August. So by then you will be having your TortoiseBot. And one more thing is that if you buy TortoiseBot, you will be also getting a discount, 10% discount on the mentorship program that Rigbital Labs is hosting currently. So in this mentorship program, we will be teaching ROS right from the basics to the advanced level, where you will be capable enough to make a robot of something like this of your own. Okay, so you can simulate the robot, you can design the robot. So all these things are taught in ROS mentorship program. And if you buy TortoiseBot, you will get an offer of 10% discount. Okay, so this is one thing that we wanted to announce, and we were really excited for this. If you want to see what all TortoiseBot can do, so you can just go over to our Instagram page, where we have uploaded many real videos of robots, and as well as simulated videos of what it can do. So here is some videos of like it was going in circles, it was doing line following. Then there was a video of it was following an object. It can also do wall following. It can also do a mission control planning. So you don't have to manually control the robot, tell it one by one. So you can just set the missions, like we have to go at position number 1, you have to go at position number 2, then pick up something. You can set such missions, and if you just press go, your robot will start moving autonomously and you don't have to control anything. So all these things can be done on TortoiseBot, as well as there are simulations available, and everything is available. It will be open source. So definitely go and check it out. Coming back to the presentation, so right now it was all about Repeater Labs, and so a little bit about me as well. I will start with my own introduction. So I am a 23-year-old mechatronics engineer and a robotic enthusiast. The reason why I am here right now, and I have been winners of 20 plus national as well as international hackathons and robotics competitions when I was in the college years. So in the 4 years of college, I have participated in various competitions and I've won 20 plus of them. I have also interned at HAL, which is Hindustan Aeronautics Limited, which is the company that makes fighter planes for the Indian Air Force. So I have done my internship over there, and like I have been working with various other companies since I was in college, but every time it was like I used to give them some ideas. I used to consult them about some new projects that they can do. So why not to make our like the thing that we do into a career? And that's the reason me along with my friends we started Repeater Labs 1 year ago. So hence I'm a budding entrepreneur. We have just completed 1 year. There is a long journey ahead, and I must say, like within 1 year, we have achieved a lot, and we have also received so much love from you guys that I'm looking forward to receive the same in the upcoming years. Okay, and apart from that, I love sharing my knowledge, and that's the reason I also have my YouTube channel. You can just go and search Pranshu Tople. And as I said, like right now I'm working with Repeater Labs, and I work around robotics, automation, machine learning, computer vision, and software development. So there are a lot of things that we do as we are a very small company right now. So most of the things, it's just me and a couple of our interns and the complete core team who work on it. So each and every person on our team is multi-talented. It's not just like one person is good in mechanical, one person is electronics. That's not the case here in Repeater Labs. In Repeater Labs, everyone is multi-talented and everyone knows multiple skills. Amarnath is asking in chat, like, sir, you graduated from which college? So I have done my graduation from Ajinkya D.Y. Patil University, Pune. Okay. Yes, Vikram, you can check it on LinkedIn, but that's completely okay. So if you have any questions, just like go and ask in chat, or you can just unmute yourself and ask it. Okay. So it's a really common question, but yet many people get dropped out of it. So this was one of the major questions that we provided for the Google form for participating in IRCKT. And I've seen a lot of good answers as well as a lot of terrible answers. So is there anyone right now here who would like to tell me what is a robot? This is all about Indian robotics community. So just go ahead and mute yourself and tell me.
So can I speak, sir?
Yes, sure.
Sir, it is a combination of mechanics, hardware, and computing, sir. Software, hardware, and design.
That's really good. That's really good. Is there anyone else who has some other definition?
Robot is, in my words, I would describe it a robot as something that makes it easy for humans to do menial jobs now.
That's really great answer. So we can say robot is something that makes like jobs for humans easier, as well as it consists of mechanical and electronics and computers, like combination of the things that the previous person said, right? So it is a combination of both. So that's a really great answer. It is something which helps human, and which has some mechanical parts, which has some electronics parts, and which has some coding and software kind of thing. So tell me, is this a robot? I usually keep on asking such questions. Okay, so because every time I get new answers and I am really astonished by the answers that I get. So most of you have attended my previous sessions as well, so don't get bored, but these are the questions that I really love. So is there anyone else who would like to say, is this a robot or not? Krish is saying fictionally yes. A robot or machine doesn't require human intervention to control it. Akshan, you are saying a machine that doesn't require human intervention to control it. So if you could think about a manual control robot, which is used in Robo Soccer and kind of those games. So is that not a robot? If that's the case, then the whole Robo Soccer name is waste. So is it something which doesn't require human intervention? Okay, so the major question, is this a robot? Could anyone unmute themselves and tell me, is this a robot or not?
Yes, it is a robot.
Sahas, could you tell me why?
I mean, okay, so it's A, mechanical, so generally robots are considered mechanical. B, it has its own intelligent systems to control and navigate its environment. C, you have its own AI and computer vision processing systems, which which help it again enable interacting with its surroundings. Also, it helps humans. So there is one point.
Okay. Yeah. So in short, you want to say that it senses its surrounding, it processes the data, and it gives some output, right? So that's the reason it's So that's yes, sure.
Sir, it looks like an animal, or it looks like a organ or something, but it's not made of natural. I mean, it is made up of steel and these kind of things, and it can have some. It can have surroundings.
Awareness of the surroundings.
Awareness of the surroundings.
Yeah. So you are saying it should look like animal. Is it something like that? Like robot should look like human or animal. Is it something like that?
Like
so this doesn't look like animal or a human being to me. So is this not a robot?
Mimic, sir. Mimic of.
Okay, mimic. So you want to say like mimic the human brain, maybe something like that, right? Sensing the surrounding and reacting.
Yes, sir.
Yes, that's a better answer. That's a really nice answer. Yeah. So yes, this is a robot because like Sahas has already told all the things that makes this a robot. So I won't go over it. But the reason why I am going through all these things because this is all going to add up in the robot operating system. So why should we learn robot operating system? It is going to add up into that. So now tell me, is this a robot?
Also, yes. Similar reasons.
Also, okay. Same reasons, sir.
But except it'll help, instead of helping, it'll kill people. I mean,
Okay, fine. So instead of helping, it will kill people. Okay. But apart from that, everything.
It is cyborg.
Yeah. So cyborg is like a human-like robot can be called as humanoid or a cyborg. But technically, the term cyborg is a combination of human and machine. Okay. So whenever somebody uses a bionic hand, that is called as cyborg. This is not a cyborg because this is completely a robot. Okay. So when there is a combination of robot and a human, that time it is called as cyborg. Okay, did you get my point?
It using
what? Hello? Hello?
Yes, sir.
Am I audible? Yeah, am I audible?
Yes, sir, you are audible. Continue.
Okay, then we will continue. Okay, so tell me, is this a robot then? So Terminator was a robot. It is just an armor. Okay.
50-50.
50-50.
It's a cobot actually, I might say.
No, sir. It's next to one. Yeah. Something like an exoskeleton. It's human-aided robot.
Okay. Yeah, exactly. This is a human-aided robot because most of the things it does doesn't require a human aid, like flying. Tony Stark doesn't have to control the flying. It has to just think about it or just do a little bit maneuvers. But the major part of flying is done by the suit itself. So there is an automated system inside the suit which acts like a robot, or which like makes the robot makes the flaps go in a way so that Iron Man can fly easily. and he can more focus on killing enemies than just flying. So that's the thing. It is a cobot. Okay. So yes. Can we call this cyborg? Then no, Akshan, we cannot call it cyborg. For cyborg, the robot part should be inside your body. Okay, so if I lose this part of hand and if I replace it with a metal arm, at that time I will become cyborg. But if I have an exoskeleton, it won't be cyborg. Okay, does that help your question? Okay, so we understood what are the robots and everything, but there is a huge controversy, okay, about the major thing, which was the laws of robotics and where the robot word came from. Okay, so let's get back to the history of robots. So robotics, this word robot came from a Czech play, which was Rossum's Universal Robot, which is shortly called as RUR. Okay, so there was a play, and in that Czech word robota means forced labor. Okay, so whatever is a forced labor is considered as a robota. Okay, and from that people thought like mechanical human beings who will be there as our laborers will be considered as robots. So robots can be used in building building huge complexes. It can be used in washing our clothes, washing our dishes and something like that, but it is something which is like a labor kind of thing. So from there it evolved and evolved and evolved, and then there were lots of different types of robots that were generated. And as there were so many types of different robots which were generated, due to that Isaac Asimov, which is a writer and a scientist, he published 3 laws of robotics. Okay, wait a minute, I guess I messed up the slides. Yes, I messed up. Yeah, I messed it up. Okay, no problem. So that led to the generation of 3 laws of robotics. Okay, and that 3 laws of robotics should be followed by any robot. And this was the another question that you received in the IRCKT question bank, and that's the reason I am keeping this session open for all, because I want to share this knowledge, and this is because the basic knowledge that all of you get. Okay, so according to the 3 laws of robotics, the first law says that a robot may not injure a human being, or it may not in action allow a human being to come to an harm. Okay, so this is the first law of robotics. Similarly, there is second law which says it should obey all the orders given by humans. So if I say go and clean the toilet for me, it should do that. But if I say go and kill a person, it shouldn't do that, because it contradicts the first law, right? So that's the thing. And there is also a third law which says it should protect its own existence until and unless this conflicts with the first and second law. So if I try to punch a robot, it should try to avoid the punch, but it should not punch me back. Okay, so it should defend itself, but it should not harm me. So usually people just tend to know about these 3 laws of robotics. They just think about that, and that was the trick question into the IRCKT Google form, because there are not actually 3 laws of robotics. There is also a 4th law, more commonly known as the 0th law of robotics. Okay, so if you just search on the internet, okay, I will just give you a thing, like I will give you an insider, like this is what I follow. Never search on internet what you are looking for. Always search that it is wrong. Okay, so if I search 3 laws of robotics, 3 laws of robotics, so it will always say that there are 3 laws, there are 3 laws. I can only find things about the 3 laws of robotics. So this narrows down my brain power. Okay, so as this is knowledge transfer, that's the reason I'm saying how to search for proper knowledge. Okay, so if you just search for 3 laws, you will think, yeah, there are only 3 laws of robotics. But if you think, if you search, there are not 3 laws of robotics. If you just add this, you will find to know, you will understand more and more things. it says there is the fourth law written by the authors Asimov. So this is when you come to find more and more things in a prominent way. Okay, so if you just say that Earth is flat, if you just search for Earth is flat, you will get a lot of things that Earth is flat. But if you search for Earth is round, you will get those things. So that's the reason. Broaden your mind and try to grab as many things as you can. So let's check out what is the fourth law of robotics that we get to know. Okay, so the fourth law is this, the zeroth law. Robot may not harm humanity or inaction allow humanity to come to an harm. So it means not only one singular robot, but it should not like by chance if humanity destroys itself due to some natural calamity or something. So the robot should not allow a humanity to come to an inaction, right? Come to an harm. So that's the reason at that time, robot will go and save at least one or two people just so that humanity can exist. So that's the zeroth law of robotics. Okay, so always broaden your search. That is what I would recommend. Okay, and we lost the presentation. Yeah, we are back here. Okay then. So this is one thing, like whenever you are learning, try to learn from anyone. Even if the person is younger than you, that doesn't mean he has less knowledge. If he is there with you, that means there is obviously something in that person which could help you. Okay, so let's get back to our presentation. So as we are studying about the history of robots, so let's look at the first industrial robot, because that is what we are focusing on. We all of us already know how to make toy robots, but we are focusing towards the industry, right? So let's get to know about the industrial robots and what how it started. So in the year 1954, it was the year when the first industrial robot called as Unimate was introduced. Okay, so this Unimate robot was just a simple robotic hand with a gripper and an arm like this. So it used to just pick up something and place it something like this. So all the repetitive tasks that were there in the industry that were covered by the these kinds of robotic arm, and that is when everything got to come into place and more advancement into robotics started. So once Unimate was there, then in 1978 Puma was released. So as you can see in this Unimate picture, there is also only one hand that goes up and down, and this looks like a big Xerox machine, right? But here it was a more compact robotic arm, and it had more motion. So this looks like the modern robotic arms that are used in industries right now, right? So this was where it all began, because they started adding more and more joints to the robot so it can have more and more flexibility. Okay, this robotic arm had just three motion of axis, three DOF, sorry. So Gaurav Khanna was asking how many DOF, so it only had 3 DOF. Okay. Later on, in the 1980s, it started to boom a lot. There were many companies that were coming with their own robotic arm designs, and that was when SCADA arms, robot arms that are used right now, they came into the picture. After that, people started adding cameras over robotic arms so that they can be more intelligent. They can understand what to pick and where to place. So that is why this robotic arms with cameras started to come. The first robotic arm was Cognex Insight. So in the name sight, that means eyesight, right? So that's the reason it all started. Even Unimate had only 2 DOFs and 1 linear motion. Okay, so it was just up and down, and it used to rotate. So this was 2 degrees of freedom, and the third joint was it could extend the arm. So that was the degree of freedom for Unimate. Okay, and later on, people started adding more and more joints. So this was the first manipulator with 6 DOF, And this kind of robots are right now used in industries with 6 GOF robot, 6 GOF joints. So it all came into 1980s. So that was the era when everybody was starting making robotic arms, because that was very much used in industries. After that, the evolutions like stopped a little bit, but the applications got broader. Okay, so the robot arm remained the same. So even if you see this robot arm of 1980s, even and if you compare it with a modern robotic arm, it looks similar. So the innovation stopped, but the applications got wider. So in 1995, the robots were made so that they could go to extraterrestrial lands and they could explore. So for that, they used the same robotic arm and they added into Mars rover. They added onto a lot of other stuff. And in 2003, NASA launched its first Mars rover, which landed onto Mars, which had robotic arms on it, and that could do exploration. Okay. And if you see currently, even right now, there are similar kind of innovations that are happening. Like you can see robotic arms with hands, so they have robotic arms and they can move. So it can be either a self-driving car or it can have proper legs. So that is the maximum that we can reach right now with respect to the mechanical designing of a robot. Okay. So now, as I discussed, like there are self-driving cars. So even these are considered as robots because they can sense the surrounding and they can enact out of it. Okay. Even then, there was Boston Dynamics is right now making these kinds of robots, which are robot dog, and these robot dogs, like they can go at places where humans can't go. Okay. So whenever in the previous years, robots used to have wheels. So, but in rough terrain, those wheels won't be able to move. So at that point of time, people started making human-like two-legged robots or four-legged robots. Okay, and that evolved into Boston Dynamics. Okay, and then there were AIs that were added to the robot. So, and that gave birth to Sophia. So robots became more intelligent. So as I said, mechanical evaluation of robots stopped after a little bit, and that's the reason people shifted towards software. So people started making robots more and more intelligent rather than more and more new designs and stuff like that. Okay. So now you know all these things. So that is of the we learned about the past and we learned about the present. So right now, does anyone can anyone say if is Iron Man a robot or not? Does anyone have any other views on it? Robotic suit. It's a robot. Tapan Patil, why do you think it's a robot? Could you unmute yourself? Jarvis operates it.
There is Jarvis. Hello, am I audible?
Yes, you are audible, Tapan. Go ahead.
Jarvis means it has built-in. Jarvis operates it like that. Before you said that the flying is done by the automated. I guess it is Jarvis does this. Means the Tony Stark just wears it. He doesn't do anything like that. Everything is done by Jarvis.
Yeah. Okay. So right now, what is happening in the industry is people are already fed up of making robots that could work at one specific thing. Okay. So people have already made robots that can be used in factory to pick and place things, but they are more looking onto combined robots. Okay. So here, if you know about the more advanced Iron Man suits, so Tony Stark doesn't need to be inside the suit, right? He can be outside the suit and he can still control it. So those are proper robots. So people are thinking to make some robots that could have combination of machines as well as like human controlled machines as well as their own intelligence. And if a human is assisting onto that machine, if human is operating that machine, the machine should assist human in doing that work. Okay. So if there is no Tony Stark inside the suit should aim for the bad person. But if Tony Stark is there inside the suit, it should help Tony to aim at the bad person. So that's how it works. Okay, so there are more complex robots, and that's the thing. If you are learning right now as a mechanical engineer, or if you are doing an electronics engineer or computer science, anything, you cannot stick to one specific field, because industry is already innovated in that one specific field. Right now, all you need to do is a combination of things. Okay, so if you should have at least 2 skills inside you to get a proper job into an industry where you can survive and sustain. Okay, so that comes to the point of automation and robots. So there is a common misconception like automation and robotics is one and the same, but there is a really big difference between automation and robotics. Okay, so automation is kind of thing where you can say there is a machine that is designed to do one specific thing. Okay, so let's consider a bottle filling machine in a factory. So the only and only purpose of that machine is to fill the bottle. It cannot do anything else. Okay, but if you in robots, it can do a variety of tasks. Okay, so if you say if a company buys a robotic arm, the company can use that robotic arm to pick and place stuff. The company can make the same make use of same robotic arm to weld things, and it can use the same robotic arm to do packaging and a lot other things, right? So it's all upon the company. What should we do with one robotic arm? So they can just buy one robot and they can do a lot of things out of it. So that was the flaw of automation. Like whenever you have to shift the company, or whenever you have to shift the production pace, so at that time you need to change the whole machines. But instead of that, right now robots can be programmed again and again so that it can be used anywhere. Okay, these are the essential characteristics of the robots that usually have. So mobility is considered as the robotic arm capabilities, like it has the ability to move. Okay, so it can have wheels, it can have legs, it can have anything. Okay, but again, innovation in this field is over. With the Boston Dynamics Spot, they have made the most small and the most powerful motor that you can make. Okay, so right now the innovation in that field is stopped, so you cannot go ahead with mobility, but your robot should have that. Okay, let's leave programmability a little bit. Let's check about the sensors. Okay, so sensors, so there are already cameras, there are LiDAR sensors, there are ultrasonic sensor, IR sensors, there are a lot of sensors, and these sensors helps robot to get a perception of the surrounding, to know about the surrounding, and that is why sensors are necessary. But again, innovation in this field is stopped. There are no new types of sensor which are being invented daily. Okay, so again, you cannot rely on sensor making as an electronics engineer as a job. Okay, so you cannot rely on that. The next thing is mechanical capability. So yeah, your robot can obviously move because it has the mobility, but what happens if it moves to a particular place? If I tell a robot to just go and bring a bottle of water for me, it will go to kitchen, but it cannot pick the bottle up. So that for that specific reason, it should have a mechanical capability. It should have a robotic arm, or it could have anything. It could just collide to the wall until the bottle fills up in the basket. It can even do that, but it should have some mechanical capability. Okay, and again, coming to the same point, people have already made advanced robotic arms with 6 DOF, 8 DOF, and even more than that. So all the innovations that could have been done in mechanical capability is already done. Okay, again, the flexibility. So your robot should be flexible enough that it can be used at n number of places. Okay, so as I said, I can say a robot to go and bring me a water bottle, it will go and bring me that. But the same robot should be able, I should be able to reprogram the robot in order to wash dishes for me, in order to do anything else like clean toilet for me or something like that. So flexibility is one point. And how can we achieve flexibility is around programmability. And that is the reason like industry is focusing only and only on programmability right now, because using programming, you can use one single robot at various different places. Okay, so you don't need to make new robots every time. You can just use one robot. You can just program it to do something else, and it might be able to do that specific thing. And that's the reason programmability, and there is no restrictions on programmability. There is no restriction on innovation, because you can think n number of applications every day. Like right now, I am feeling tired to just adjust this light over here. So I can make a robot for that. I can program my robot to do that. So there are tons of applications that can be done using robot. Just the thing is, you need to know how to program a robot. Okay. So as we already saw, like this is the common key components of the robot, which comes to the power supply, controller, sensors, motors, user interface, and linkage. So there was another question into your Google form, because of which I added this to you. Okay, so there was a questions about what is the part of the robot that have movements and stuff like that. So technically, those are called as actuators, which comes under the motors. Okay, so robot is similar to a human being, where you need a combination of organs to work together. So just like human needs food to survive, to earn energy, similarly robots need power supply, which is a battery. Okay, and what does battery do? It provides supply to three major things. It sends the power to sensor, it sends the power to controller, and it sends power to motors. Okay, so just like humans have eyes and other sensory organs, so robots have cameras, IR sensor, ultrasonic sensor, or any kind of these stuffs. Okay, so all kinds of sensor. So they help robot to understand the surrounding. Okay, so if you it was okay in the past if you removed sensor from robots, because at that time it was not very important for robots to be autonomous, but currently people want as many things as possible as autonomous. Okay? And that's the reason why people are focusing so much on sensors. After that, the power supply is sent to motors, so that we can power the motors and we can move the robot. But how does this processing happen? So the sensor sends the data to the controller, which is the brain of the robot. It sends the data, like I am able to see a robot in front of me. So the eyes are sending the data to my brain, and then my brain is processing, like if you want to pick up this robot, you have to place your hand, you have to move your hand like this, you have to first move your shoulder, you have to then move your elbow, and then pick it up. So this is how I can pick up this robot, right? So similar kind of instructions are given to the motors using the controller. So this is the brain of your robot. And a combination of motors makes into linkages. So right now I have a motor in my shoulder, I have a motor in my elbow. So if can I just pick up this robot using my this joint, like one specific joint? I cannot pick it up, right? I need combination of all these motors, even these small kinds of motor. I need combination of all of them. So these are considered as linkage. Like a combination of motors is considered into linkage. And always, like you can see, these are already one-way arrows. So power supply sends these things, sensor sends data to controller, controller sends data to motors. But there is only one two-way connection, which is user interface. Okay, so just like let's say if my brain is saying that, okay, Pranshu, you are tired, just go to sleep. So what my brain will do is it will send commands to my motors that just go to bed and lie down. It will give that command. But sometimes it happens that even if I'm tired, my heart says that I want to watch a movie on Netflix. So that is an extra value addition from the heart, that we want to watch a movie, or we want to contradict the commands given by the controller, right? So that is when user interface comes into place. So let's say if robot is just going forward for some other task, but if the user wants the robot to go somewhere else, if the robot says no, if the human says don't go forward, just go left side, so in that time user interface plays an important role. And what is happening currently in the industry is everybody is focused on these 5 parts. 1, 2, 3, 4, 5. These things are already there. But there are very few people who are working on user interface, because until now, the smart robots that were made, they were made only for testing. They were used in controlled environment. Okay, and this controlled environment can have people who are intelligent in robotics. They can have people who can code at the time and change the things. They can operate robots using terminal, and they can do a lot of things. But what happens is, when these robots are sent to users, they don't know robot coding, they don't know anything, and that's the reason they need to have a user interface. So in this knowledge transfer program, we will be learning how we can make user interface for the robot. So if you want to override something, or you have to send some data to the robot, how you can do that using a user interface, not a terminal. So we will be learning that in this knowledge transfer program. Okay, so here are a couple of things like the mechanical elements that are used in robots. Okay, so if you are not a mechanical engineer, this might help you out. Apart from that, as I said, there are two types of robot: manual controlled robots and autonomous controlled robots. Okay, so there are some autonomous robots that we won't be checking out right now, but we will be checking out manual controlled robots because we want user interface right now, right? So for user interface, we will be just checking about the manual robots. And apart from types of robots upon control, there are also types of robots according to locomotion. So depending upon where you want to move your robot, depending upon that, there are types of robots. So you can have stationary robots, which can be work like a robotic arm. There can be wheeled robots. You can have single wheel, 2 wheel, 3 wheel, 4 wheel, 6 wheel. You can have as many as you want. You can have legs as well. You can have 1 leg, 2 leg, 3 leg. There are a ton of leg options as well. And apart from not legs, you can have swimming robots, you can have flying robots. So there are tons of types of robots that you can have depending upon locomotion. And this is important because this is responsible for the environment of the robot. So depending upon the environment, you have to choose which kind of robot you are going to use. And at the end of the session, I will be having one more thing for you guys. So usually when companies approach us, they approach with a problem statement. Okay, and there are a couple of things that you need to consider in order to give the solution to that company. So that thing I will be discussing with you at the end of the presentation. Okay. So yeah, so where are these robots used? So right now you saw different types of robots. So where can they be used? So they can be used where it is dangerous for humans to go, or it is not efficient for humans to go. So you cannot send humans to space because space programs are really long and they are really expensive as well. You cannot just send a person, bring him back, send a person, bring him back. You cannot do that again and again. So for that, robots are being sent. So they are sent once and they can be just kept over there. So these are the places where robots are used, and even at radioactive places where you have to do some disaster, like after disaster cleaning and stuff like that. So there you can send robots. After that, places where people are bored. Okay, so if people are bored of picking and placing one single stuff, their robots can be used. After that, high precision things, so where surgical things, where minute precision is really needed, at that time robots are used. Because if I want to just cut a paper, no matter how I want to cut it, I can just use anything. You can just keep a person to do that. But if I want precision, I want a robot. Okay. So we already saw this, like what makes a robot, but here we will just look at the things that are already present, and we will compare it with the actual parameter. So first of all, we need a brain, right? The CPU. So the CPU should be powerful, but it should be small and it should be low energy consuming, right? So what CPUs do we use today? So there are netbooks, there are just a minute. Yeah. There are netbooks, there are Intel NUC, there is Jetson Nano and Arduino and Raspberry Pi. There are a lot of CPUs that are used. After that, we have sensors. So in sensors, we want to sense the surrounding. So that's the reason we use LiDAR. We use IMU for knowing the orientation of the robot and the movement of the robot. So these are the sensors. Sorry, these are the CPU. This is the sensor. So sensors and actuators. Actuators means the motors. It can be stepper motor, servo motor, or any type of motor. So these two are connected to the CPU using interfaces. So you can do analog, serial interface, digital interface, or UART, SPI. So these are the types of communication that you can do between a robot, the brain of the robot, and the motor or even a sensor. Okay. And finally, these all things are dependent upon power supply. So this is the thing. This is the major thing. But what about the operating system? Okay. So you can consider operating system like the soul of the robot. Okay. So you cannot see it working, but it is the major thing why a robot is specifically doing that specific purpose. Okay. So that's the reason that comes to the point operating system. And if you look at the operating system, so everybody is using phone right now, or desktop PC, laptop PC, or something like that. So all of them have an operating system. Why? To make it unified. So let's consider I'm using a Windows laptop today. If I go to my friend's place, even he will be using a Windows laptop. So if something works on my PC, it will also work on my friend's PC, right? So that's the major factor. Like everything will be universal. So in robotics, in the early days, as each and every company was making their own robots, there was not one single operating system that could be unified everything. So let's say if I am working today for let's say ABB, I'm working for ABB company, and I'm working on robots. And let's say tomorrow I go to Boston Dynamics and I want to work over there. So I have to learn again some new things because they won't be using same operating system. So this was a huge drawback in the past days, okay? Because each and every company used to work on their own software. They used to work on their own robot. So when people used to switch jobs, or there was no unified job as well, okay? So each person, if you are going at a new company, you have to start from training. Even if you have 10 years of experience, you have 10 years of experience in wrong field. So that's the reason you have to start from the beginning. And to avoid these kinds of stuff, ROS was introduced. Okay, so we want along with ROS, what came was it had less programming work. So you don't have to program the robot in ROS. You don't have to write whole code. In ROS, you can just use somebody else's code and you can easily combine them. You can have simulation. Okay, so you can simulate robots. Apart from that, ROS is technically free of cost, so it is at a low costing. So even all the industries can use ROS. Apart from that, it has many softwares that are already present. So you can use communication. So you can communicating with motors and sensors. You can use motion planning to plan the path of the robot. You can use navigation to navigate your robot. You can have robotic arms, different robotic arms working on same operating system. So no matter in which company you go, each company will be using same type of software for single robotic arm. So everything was available in ROS, and that's the reason industry accepted ROS and people started using ROS. So the main goal of ROS you can consider is to stop reinventing the wheel. So let's consider if some company made a robotic arm with a camera, okay, and they have something like they can recognize a mobile phone and pick it and place it. If a company has already done it, if the other company starts to do it, they have to waste their resources on it. They have to put their man to work over it, and what happens with this is there is no innovation happening. Everybody is just making what is already been made, and that's the reason to focus more on innovation. Robot operating system was made so that what is already there, don't waste time on that. Make something new. Okay, make something new, make something better. So that is the main goal of ROS. Moving ahead. So ROS was not something which a company made. ROS was initially a project by students at Stanford University. Okay, so they made ROS, and then it was occupied by Open Source Robotics Foundation. They acquired the students and their project, and that is when they started making applications around ROS. And the future goal of ROS is to be the standard about robotics. Okay, so each and every, like right now, 80% of industrial robots are using ROS, 20% are still the old robots. But the main goal of ROS is to have each and every robot on this planet to work on the same operating system, so that robotics engineers, when they shift jobs, when they move from one place to another, they could use the same software. Yeah, so coming to the point, which is what is ROS. So ROS is considered as a meta operating system. It's not an operating system. Okay. So right now, what does meta operating system means is it works on another operating system. So currently, you need a specific operating system for ROS to work. It can be Ubuntu, it can be Windows, it can be macOS, it can be anything. But over that, there will be robot operating system. Okay. And there is hardware abstraction and low level device control. So even if you want to control Arduino, you can do that. If you want to do higher level device control like Raspberry Pi and motion planning, path planning, even that can be done using ROS. And ROS has all the hardware abstraction, like each and every sensor has their ROS libraries. Each and every robotic arm, no matter which company's robotic arm you use, they have ROS packages for them. So you can, if you are not happy with one company's robotic arm, you can easily shift to other company's robotic arm, but you don't need to change anything in your package, because ROS sends some commands. Okay, so those commands are encrypted. Apart from that, you can change the device. So even right now, I'm using one company's LiDAR. If I don't want that, I can just remove this LiDAR, I can place some other LiDAR, and it should work exactly the fine. I don't need to change anything. I don't need to change any code. It will work exactly the same. Okay. After that, it has tools and libraries which are made on C++, Python, Octave, Lisp, and Java. Most commonly, Python and C++ are only used in ROS, but others are also available. So you can, if you know any other coding language, you can make in that as well. Okay. And it supports different operating systems and hardware platforms, but works best with Ubuntu and Linux. So as I said, robot operating system can work on Windows as well. It can work on macOS as well, but it works best on Ubuntu. Okay. And no, macOS is not considered as meta operating system. So when you run VM on macOS, so VM is a meta operating system. macOS is the proper operating system. The kernel is Unix or Linux. Okay. Yeah, and turns out to be more and more standard for mobile robots. So all those robots, so as you saw right now, this robot, it can map the surrounding, it can move autonomously. So most of these things are used in industries, and most of all those robots, like not most, all of those robots are using ROS right now. Okay. And it is spreading into industrial environment using ROS Industrial. So ROS Industrial is a separate package which is especially made for industrial robots. Okay, so I will be showing you that. So why ROS Industrial was introduced? So previously, as I said, there were a lot of programming language, different programming languages that each company used in their robotic arm. Each and every robotic arm had different operating system, different coding languages and stuff. So all these things was generalized using ROS. And what happens is if I have a network of companies, I can switch between different robotic arms easily. So even if I want to make a mobile robot, I can switch that. I can do different combinations of sensors and different robot parts, and it is really easy in ROS. So that's the reason ROS Industrial was made, and this ROS Industrial have packages of all these companies. Okay, all these companies are using ROS in their day-to-day life. They are making ROS packages for their robot. So let's say if you're working for BMW based robots, and if you switch your company to Bosch, so even they will be having similar software. So even if you're working at Boeing or any other company, most of them have the same robot software. Okay. So this was it for today, but I have one small thing to add, which is like most of the people kept on asking on IRC as well, like is actually ROS used in industries and how is it used? How you get clients for ROS, or uh, it how they choose which how, like what type of robot they want to use. So there are a lot of such questions. So the secret thing is, whenever a client comes to us as Repeater Labs for making a robot or for consultation of a robot, so there are a couple of things that we ask. Okay, so there are a couple of parameters. So first parameter is we ask what is the working volume. If it's a small area, we could go for robotic arm. If it's not a small area, if it's a huge factory, at that time we need mobile robots. We need robots that can move around, and that can be using wheels or using legs. So if the factory is very evenly floored, we use a two-wheel robot. If it has small bumps, we use a four-wheel robot. If it is unterrain kind of thing, so not terrain, like a little bit of obstructions, a little bit of obstacles, then we can use track belt robot. If it is a lot of destruction, like disaster management and stuff, so at that time we use quadrupedal robots. So depending upon the movement where the robot is being used, depending upon the locomotion, we use these kind of robots. And if there is no land or if there is no proper walkable surface, at that time we use drones. Apart from that, if the working volume is small, so at that time we know we have to use a robotic arm. But which type of robotic arm? There are tons of types of robotic arms that you can see over here. So depending upon space in which the robot has to operate and the volume in which it has to cover, depending upon that we choose how many types of robot, which type of robot do we want to use. Because when each type of robot, if you make more and more advanced robot, it will cost you more and more. So see, this is just a basic Cartesian robot. So it just goes sideways, forward, backward, and up, down, and up and down. So this is kind of a CNC router that you have, or even 3D printers that is there. So instead of using that in 3D printer, I can use a fancy robotic arm to 3D print stuff, right? But that will cost you a lot. And that's the reason we don't use robotic arm to 3D print stuff. So you have to choose which type of robot you want to use depending upon the working volume. The next thing is speed and acceleration. Okay, so the speed and acceleration, like at what speed the robot has to move, and how fast should it go. So faster the robot goes, the less accurate it becomes. There is less resolution. Okay, so let's say if my robot speed is going very fast, so even if I just give it a 1 millisecond of voltage, it will travel 10 centimeters. So that is the resolution, like in minimum amount of voltage, how much it has moved. It has moved 10 centimeters. So I cannot be precise to 1 centimeter thing because it is moving very fast. So at that time, if I want precision of 1 centimeter, at that time I have to reduce the speed of the robot. So depending upon that, we have to choose what speed and acceleration do we have to go for. Okay, and then also it depends upon the speed of the actual task. So let's say in case where it is welding, so you need to hold a welding rod a little bit of time on the metal. So you can make a very fast robotic arm which draws something like this, but it cannot weld at this speed, right? For welding, it has to go slowly like this and make the complete motion. So at that time, there is no use of putting extra money in buying heavy duty robotic arms and fast robotic arms. At that time, you need resolution, which comes to the third point, which is resolution, the smallest step a robot can take. So in wheeled robots, it is like the smallest motion the robot can go. So you can see this is the smallest motion that this robot wheel can move. Apart from that, if you look at the robotic arm, so what is the smallest, does it go 1 centimeter ahead or does it go 1 millimeter ahead, depending upon the angles. So what is the resolution? That is also important in the industry. So these are the three major factors that I asked to the client, that what are these three answers. And after that comes to the two major points, which is accuracy and repeatability. So there, if you remember, there was another question in IRCKT Google form, which was, do you think accuracy and repeatability is same? So is there anyone here right now who would like to answer this question? Is accuracy and repeatability same?
No, accuracy is something, how close to the true value, how true, something, what we're measuring needs to be very close to the true value to be highly accurate. For high repeatability, even if you're off by 100 in accuracy, you need to be very close to that value every single time you do the test. Every single time you do the test, even if strong value, it needs to be the same correct value. Like it needs to be near that value.
Okay, so that is a really nice answer. So accuracy and repeatability are a lot different. So consider this thing. Consider we are making a delivery robot. Okay, so we are making a delivery robot for Domino's. Okay, and consider I order pizzas from Domino's every day. Okay, so every day I order at my place. Okay, so if every day, if my robot comes to my place to deliver that order, that means it has high accuracy, high repeatability. Okay, so let's see a graph to understand this in a better way. So let's consider this. Let's consider this blue box is my house. So every day the robot comes to my house. So that means, okay, it has high accuracy and high repeatability. So now let's consider if I every day order a pizza, and every time, each and every time, the delivery robot goes and delivers it to my neighbor's place. Every time, okay, each and every single time. So that means my house is here, but the robot is delivering somewhere else and at the same location, at the same neighbor. So this means accuracy, repeatability is high, because each and every time it is repeating itself. It is repeating its mistake. Even if it's a mistake, but it is repeating. So each and every time it is going to the same neighbor. But accuracy is low because it needed to come to my place, but instead of my place, it went to my neighbor's house, right? So in this case, you have you can just shift these complete, like your performance of the motors and everything is good, but you can just shift the code and you can tell the robot to go at some other place. Okay, so this is high repeatability and low accuracy. Now consider every time I order a pizza, sometimes it comes to my place, sometimes it's come to my one neighbor place, sometimes it goes to my neighbor who is living above me, and something like that. So each and every time it is going to different person, but it is close to my place. It is close to my place. So here you can see it is close to my place, but at different positions. So this means accuracy is high. So it is coming to the position, like it is coming to my building, it's coming to my society, but repeatability is low because sometimes it is coming to me, sometimes it is coming to my neighbor, sometimes it is going somewhere else. So repeatability is low. So at this time, what you need to do is you need to work more on the robot part. So what is causing this problem? It can be some software issue as well as some hardware issues, because sometimes what happens is your wheel slips too much. Because of that, it doesn't reach the exact place. That might be the problem. So this is one thing. And sometimes it happens like low accuracy and low repeatability. So here I am living here in Pune. If I order something over here, it goes and delivers it to Mumbai. So this is like there is no accuracy, and sometimes it goes to Mumbai, sometimes it goes to Delhi, sometimes it goes anywhere else. So if you are in this fourth quadrant, okay, just leave robotics. Robotics is not for you. Okay, either leave robotics or try to go in any of these quadrants. You cannot go directly from here to here. You cannot go diagonally. For that, either you need to go up here and here, or else from here to here and then up. So this is the major thing that is being used in industries, because this delivery robot was just an example, okay? But in industries, there are very minute things that needed to be done. There are minute spots where there needs to be welded, and at that welding position, you need to reach that exact same welding position each and every time. Even a here and there can make you a loss of thousands and crores of rupees, okay? So that is really very much important in industry, and that is the reason in industries jugaad never happens. You need to make it in proper way to make it to happen. And the reason why I am saying this is in the next few days in IRCKT, it is going to be rigorous, and that's the reason we will be shortlisting few people. It is not for everyone, it is for a limited number of people, but all the people who will be there, don't try to go for jugaad. Do your work properly, because that is going to help you at a longer run. Okay, so with that said, that was it for my side. Do you have any questions for today?
Thank you, Francis sir. Before
Yes.
we start off the Q&A, I really want to thank you for the session today, and also for on behalf of all the attendees, because we believe that this session which you have conducted to make it open for all, it might have really hit every enthusiast who want to work on ROS, and the
Yes.
way you have explained it, it really made us clear about what process. So, and for the Q&A session, yes, everyone, we are open for the Q&A session. Please, one by one, I wish everyone I would like everyone to go on with their questions.
It can be related to IRCKT, it can be related to the presentation or anything.
I think Sahas was about to ask some question. I just interrupted him in between.
What's the schedule for next session of IRCKT? So somebody, Manav Thakkar is asking in chat. So these next sessions of IRCKT will be similar. So in the evening at the same time, similar time, you will be given proper schedule for it. So next 2 days, we will be teaching you some concepts about robotics and ROS. We will be trying it out. And also I will be showing you how you can make graphical user interface for robots and stuff. And after that, there will be a competition. So you will be given a couple of days in which you have to complete that competition, and you have to upload a video on YouTube. Okay, and once you upload, you have to upload it on your own channel. If you don't have one channel, make one, because definitely it is going to help you showcase your talent. Okay, and depending upon that video, I guess you will be given a time of 1 week. Yes, 1 week you will be given, and after that, next Sunday, we will be announcing a winner. So the person who performs the best, like the top 3 runner-ups, they will be given some goodies, some prizes, even physical certificates will be delivered at your home. And apart from that, you will be getting a chance for the industrial training mentorship program at IRCKT Labs. So in that, you will be taught ROS right from basics to advanced thing. And apart from that, we will, at the end of the program, you will be working on a real life environment industrial project. So that awaits you. And if you and there is one more special prize for a person with something different. Okay, so he doesn't need to be the winner. He doesn't need to do it perfectly, or maybe he can do it perfectly. But there is a special prize. That person will be directly getting internship into IRCKT Labs. If we like his work, if we like his attitude, what he has done differently, if we really like that, that person will be getting internship at IRCKT Labs, and he will be working with the industrial projects that we are working on currently. So that is also there. And obviously certificates are there for the people at the top things that we said, the runner-ups and the winners. We will be implementing concepts which we will learn in 2 days. Talking about the prerequisites, so the only prerequisite that you have is you should have Ubuntu installed on your PC. Ubuntu 18.04. We will be using Ubuntu 18.04. Okay, so you can use a virtual machine if you want, or if you want, you can use a dual booted system. So if you want to know how you can dual boot, just a minute, I will show it to you. Is my screen visible?
Yes, it is.
Okay, so yeah. Just search my name on YouTube. You will get my channel. And on my channel, if you go on to videos, okay, it's right here. Dual booting your PC. You can follow this tutorial to dual boot your PC. And instead of 16.04 that I am using over here, instead of 16.04, you can download 18.04. So if you search Ubuntu 18.04, so yeah, so you have to download this desktop image from here, and either you can use a virtual machine or you can dual boot your system. So that is the only prerequisite that you have. Apart from that, the next prerequisite is dedication, because this is not going to be easy. Okay, this is going to be really tough, this is going to be really hard, and it will be really rigorous. And the reason we are having this stuff is because we want you to be industry ready. We want you to be like a proper working machine right now who can just go into industry and get any job. Okay, and that's the reason we will be using this. Is there anything else? There are some questions in chats.
Yes, sir. Yeah. Yes, guys. So one important announcement, Mr. Pranshu has already given you the detail. So let me clear you this thing, that today's session was completely free. It was open for everybody. Okay. So, but from tomorrow on, then for the further KT sessions, you are required to fill a Google form. Okay. You are required to fill a Google form by which you will be shortlisted, and not everybody, but only few will be attending the session. So it contains, like, the link is already shared in the chat box, right? Please go through the form. You have to fill the form by 12 a.m. midnight today. Okay. And the shortlisted people will be able to join tomorrow's session and further on. Is it clear? And the form also contains the prerequisites which are asking, like the software, whatever we require, Ubuntu and everything. Okay. And this is compulsory. Those who fill the form those who fill the form will only be eligible for the selection criteria. So I request everybody to go through the form, and by tonight I request everyone to fill the form if you want to continue further.
Yeah, and one more thing I would like to add, that this Google form is different from the one that you filled previously. Okay, yeah. So don't consider that I have already done it. This is a new Google form that you need to fill. Just make sure. Okay, Nikhila, you can.
Yes, Abhishek, it is not the same Google form. That's what we have cleared right now. It is not the same Google form link which was shared earlier for you. It is a different form, right? As mentioned, it also has the prerequisites which are required. Okay, so everybody make sure not to forget it and not to forget to fill the form. Okay. And everything is mentioned by Mr. Pranshu. So why we are actually making IRCKT is one thing. We are focusing more of you guys have an industry knowledge, and our main motive is that after attending KT, IRC believes you will be able to differentiate why and what IRCKT is by yourselves. So whenever in future, when you go somewhere and when you differentiate what KT is to the others, they will understand the true knowledge you have gained for spending the 10 long hours with us, with Mr. Pranshu as a mentor, especially. So, and also the runner-ups will be having like discounts on the mentorship program that Tribital Labs is providing, along with certificates, perks, and everything. The best thing Mr. Pranshu has already mentioned is the perk. The best performer in KT will be privileged to have under the hashtag IRCIC, that is Industry Connect, as an intern. So I request, like, it is a great opportunity for you guys who are really interested to work on ROS, and having a mentor like Mr. Pranshu is really an interesting thing. So Is
Yeah,
anybody else? Yes,
one
sir.
more thing I would like to add is like even if you don't get shortlisted for the proceeding of KT, okay, because we are going to shortlist at a very strong rate, we are going to just have limited number of people in that. But even then, if you want to learn more related stuff, so everybody who is right now here in this first session of IRCKT is given a 500 rupees discount. So we already have your email IDs, we have already have your phone numbers and like names. So if you want to get into ROS mentorship program, you are getting a 500 rupees discount. So you can just register on Repeater Labs website for mentorship, and we will be getting 500 rupees off over there itself. Okay, so even that is one perk that every one of you is getting currently, not the shortlisted perk, but everyone. Okay. Also, I would like to like answer a few more questions that are in chat currently. So Sahas is asked, like, let's get to up. Okay. Yeah, so can we use Raspberry Pi? So we cannot use Raspberry Pi because we will be simulating some robots. Okay, so for simulation, you need a laptop and some prerequisites. So Team IRC will be sharing those prerequisites with you, and you need that specific thing. Okay. After that, can everyone attend tomorrow's session? No, it will be only for the selected people. Not everyone can attend tomorrow's session. And then Akash Rao is asking, I have read about a few security issues with ROS. Even though I know ROS 2 solves the same issue, there are many people still using ROS 1 in both academics and industries, I believe. So have you encountered any similar questions on security point from industry people? If yes, how do you respond? So yes, there are some issues for ROS 1, but this has been very long back an issue. Okay, since past couple of years, like past 5 years, there is a website which is like a VPN for ROS. So VPN for robots, which is known as HusarNet. So every industrial robot uses HusarNet as a security measure, and it doesn't have any security issues. So that's the reason still many industries today are still sticking with ROS 1 and not going to ROS 2. Okay, is ROS mentorship program for beginners only or for those who have some basic? So it is for beginners as well as those who have a limited amount of knowledge. So it is focused on beginners so that we can mold them. And if you already know basics, then it is really for you because you can learn a lot of more stuff. You can learn how you can implement a few more things on as well. So you can definitely go for ROS mentorship program. Can we use Ubuntu based distro LTS? Yes, you have to use Ubuntu 18.04. No other distro, you have to just use Ubuntu 18.04. Okay, sir, my OS is Ubuntu 20.04. No, Vikram, you cannot use Ubuntu 20.04. I would recommend you to use virtual machine to use Ubuntu 18.04. Okay. Exactly. Sahas has already answered Vikram's question that it uses Python 3 and it is not supported. Yeah. So the rest of the questions are already answered. So again, I am telling you have to use Ubuntu 18.04. Nikhila, are you there?
Yes, sir, I'm in, sir.
Yeah, so just make sure everybody is using Ubuntu 18.04, no other operating system. Okay.
Okay, sure. Yes, and yes, guys. So most of you are clear with the questions and what we will be proceeding further, right?
Yes. Sahil is asking if you have already enrolled in mentorship program, are we still eligible? Sahil, for what are we still eligible for? Can you unmute yourself and ask the question?
Sir, for the 3-day workshop.
Yes. For the 3-day workshop, you are eligible for that. Yes.
Thank you, sir.
Yes, guys. So actually, I have another announcement for all the attendees who have attended the session today. So I have just shared a link for the IRC membership form, right? So we know you're much excited for the IRC knowledge transfer event. So similar events will be conducted in further coming days to come. So in case you want to get connected with us and want to know more about IRCKT and the internship program which we have started at IRC Industry Connect, so you can sign up the membership form. You will be notified about it further. Okay. And one last announcement, make sure you fill the form by tonight, not to forget. Okay. Yes, sir. Anyone have any other questions? If no questions, then thank you all for the session, and it was a wonderful session. I believe everyone have you enjoyed it and got to know what ROS is. Yes, sir. Pranchu, sir, you have anything else to say?
No, that was it from my side. It was really great having you all, and thank you very much for joining. Could everybody just turn on their cameras? We can have a group photo right now.
Yeah, that would be great.
Yeah. Everybody who is comfortable with it right now, could you please turn on your cameras? That's great. We are almost 70 plus people who are right now here in the meeting. Come on, everybody who is there, turn on their camera. Okay, Nikhila, so that was it from my side. So hope you all fill the form, and hope to see most of you tomorrow at IRCKT, because if you are being shortlisted, be ready for the most rigorous next couple of days of your life. Okay, it is going to be really difficult. Abdul has raised a hand. So yes, Abdul, could you unmute yourself and ask why did you raise your hand? Is there a caster wheel in tortoise bot for cell match? Yes, there is a caster wheel. At the bottom, you can see there is this caster wheel. And what is the other question in the chat? How is about selection process? So Nikhila, can you explain how the selection process is going to happen?
Yes, sir. Actually, guys, in particular, we are not allowed to share what the selection process is, because whatever we require for you to, whether you're having the basic knowledge of ROS, or are you carrying the prerequisites that you are having right now, that is the basic criteria for selection procedure, and based on your answers. Because initially, when if you guys remember, like Pranchu sir also has discussed most of the questions in the session, you are given few set of questions to test your knowledge on ROS. So similar questions are here as well, and not basic, not run, which are like more complicated and an intermediate level. That yes, are you eligible to attend that session? So these questions are in that form, and that is how we will shortlist you. Okay.
Okay, then should we conclude this meeting then, Nikhila?
Yes, sir. So I hope you guys are clear about all your doubts and queries you had. And like, thank you all for attending the session, because you have been really great audience for the session. We really enjoyed having you all here. Hope you also had the same experience with us. Thank you. Thank you all. Thank you, Mr. Pranshu, sir.
Thank you, Nicole.
Thank you, ma'am. Thank you, sir.
Thank you.
Thank you. Great. And the recordings for this session will also be shared with you. Today's session will be shared to you.
Thank you, ma'am.
Thank you, Aryan. Have a great day, guys. Yes, guys. Pritish and Abhinav are here. Pritish and Abhinav, anything else?